Hi everyone, we're back again for the second instalment of derivatives of an inverse trig function. This time we'll be doing inverse of cosine function. So once again, let's take a quick look in GeoGebra. The function in green here is a cosine function, nice continuous function, and I have point A here at the point 0, 1. Remember, cosine of 0 equals 1. Now the red graph is the graph of inverse cosine. So as we would remember, if the equivalent point to point A would not be 0, 1, it would be 1, 0. So there it is, that's the equivalent point on the inverse function. Remember also that an inverse function and its original function are reflections around this line y equals x. This is dotted line here, y equals x. Now, as I slide this point forwards, something, come on, why don't you want to slide for me? Oh, GeoGebra, why are you doing this to me in the middle of a video? There we go. So that's jumping a long way, but anyway, we get the idea. So as A moves forwards, then B stays as a reflection in that line y equals x, and we get to the point here where A equals pi, and the cosine of pi is -1, and that's the terminal point of the inverse cosine function. For similar reasons to what we said last time, we couldn't go any further because point B would start to curl back on itself, and we would then not have a function here for this red line. So there is a limited range. The range would be from pi at there and 0 at that point. So the range is 0 to pi. The domain is -1 at this point, and it was +1 at this point. So once again, there's a limited domain for the inverse of a trig function, limited domain and range. But back to the main event, what are we going to do in order to find the derivative of this function? Well, we'll take a similar approach to last time. We'll take the cosine of both sides of this. So the cosine of y will equal x. Then remember, the whole objective of this is to find dy dx excuse me, of the original function. So I'll take the derivative. Now on this side, as I explained last time, I'll have to take an implicit derivative. So dy dx multiplied by d over dy of cosine y, and then d over dx of x. And if we look carefully, really on both sides, I've just done the derivative with respect to x. This would cancel, making this whole business here d over dx, the same as what I did there. So with my dy dx still in place, derivative of cosine using y as the variable is negative sine y, and derivative of x is 1. So dy dx is -1 over sine y. Again, I don't really want my derivative to be in terms of the variable y. I want my derivative to be in terms of x, because this original function, y, was written in terms of x. So let's use the Pythagorean theorem again. Sine squared y plus cosine squared y equals 1. So sine squared y is 1 minus cosine squared y, and if I take the square root of both sides, then I have a replacement for sine of y. This is -1 over the square root of 1 minus cosine squared y. Let's go back and find out what cosine of y was. Cosine of y was x. So here we have -1 over the square root of 1 minus x squared. That is dy dx when we started with the function y equaled the inverse cosine of x. And that should be just about enough for this instalment of the lesson on derivatives of inverse trigonometric functions. See you next time.